Okay, so here we go with the next part. Okay, so now we're getting into a little more technical stuff when we look at two different types of growth rates. So the sort of normal natural growth rate that we see typically in nature is called logistic growth, which is a growth pattern that slows down after a period of exponential growth, which is actually a stabilizing effect. So what we see here represents exponential growth, where it grows really rapidly over a short period. And then it reaches the population. Here you see it says number of individuals, so that's the population size. Once it reaches the carrying capacity, which can be labeled K, that's why that big K is there, it will stabilize. So this is the resource limits that we talked about earlier. And I showed you another chart that was similar to this, and it had it kind of more fluctuating, which is probably more realistic. It's not going to be just like perfect like this, but this is generally seen as a logistic growth graph where really rapid growth, and then it stabilizes as organisms are not able to really go past their limits or carrying capacity. And so again, it slows down when the carrying capacity is reached, which creates a stable growth. Then we have what's called exponential growth, which is actually usually seen as a temporary thing. It cannot go on forever, basically. And this is where the human population is at right now. I'm going to show you a graph in a little bit, and this is what it looks like. It's just going up and up. And so this is a growth pattern in which the population reproduces at a constant rate. And there are some countries that we talked about earlier that are slowing down, but when we look at the overall planet as far as humans, it looks like this. So what this tends to represent is a really high birth rate, lots of organisms being born, and a very low death rate, not a lot of them are dying. And what that causes is a really rapid increase in population size, but at some point it's going to not be in balance and be unstable. And this is where we're going to get into some more stuff like endangerment and extinction topics like we've talked about before. So even when bacteria does this, which it can, they're very small and they can, if there's enough resources, they can reproduce really fast. Eventually even bacteria run out of resources and they stop going straight up like this. But this is currently what the human population growth looks like, and it's actually even steeper than this, which I'm going to show you. So normally, organisms are affected by what are called limiting factors. These are factors in an ecosystem that decrease the growth rate. Okay, so in other words, they have an increased death rate. And they're sort of how nature works, basically, in keeping ecosystems and communities stable. But if there's too many happening all at once, this can cause endangerment or extinction for organisms. So some limiting factors, I'm going to go over these right now. One of them I don't think is tremendously relevant, but can be. So diseases and parasites. So, if things are dying from diseases, that's obviously going to increase the death rate and limit their growth. And this is the one that I don't think is really that relevant. I don't think there's a lot of animals being killed by cars and stuff in some kind of level where it's like a huge deal on their population. Maybe in some areas and for some populations, but I've never really heard this is like a critical issue. Natural disasters are definitely some. If there's a big forest fire, then obviously a bunch of organisms are going to die. So we'll get into that. Starvation, that's direct lack of resources. So obviously, and that could be water too. So obviously that's going to increase the death rate. So having food and water is definitely a limiting factor. Hunting is, I don't agree with this minimal effect. Maybe this is an old picture, but we have learned, and some of you did research projects where human hunters and poachers are going out and killing endangered species and wiping them out. So that is not a minimal effect. Maybe with some animals where they don't wipe them out, like deer and stuff, it's okay. But you guys know by now, after other things we've learned, that poachers are hunting certain animals to extinction, basically, right now. Predators are definitely also a limiting factor. which we're going to talk more about. If there's lots of predators, that's going to increase the death rate for their prey. And then usually in class, I say, okay, what does the other indicate? And usually somebody figures out, like, oh, it's like humans are destroying the forest. And so I don't know why they put other. What they should have said is human impacts, because that's what it would be called. And in this case, it looks as if it's illustrating deforestation, which should be clear to those of you who learned about deforestation in your projects first semester. And so obviously deforestation, if we go in and we destroy a forest, there's going to be a big death rate for the plants, let alone the animals that live in that forest. So when we look at limiting factors, we have to look at them a certain way, and they're defined by what's called population density, which is the number of species per unit of area. So one really easy way to explain density is you might have a balloon that's bigger than a bowling ball, but the bowling ball is way more dense because it has way more molecules packed into it. And when you're on a planet, like when we're on Earth, it equates to weight. So obviously a balloon full of air is not going to weigh as much as a bowling ball also. So density can equate to weight, but in this case it just means kind of like how packed together. Just like a bowling ball has a lot of molecules packed together inside of it. So usually I say at this point, does this look like a really dense population of walruses? And the class says yes. And it is. And they are competing. So more density is going to result in more competition. Because there might be killer whales out here that are hunting them, and they need to get out of the cold water and warm up and stuff like that. And those that can't, and they kind of push each other around. So if they're not strong enough to get their way onto the land, that could cause them to die maybe for some reason, and that would be a limiting factor, just the space on this little island. And the other thing I usually say is, okay, let's imagine a virus, like a really deadly virus, was on like inside a couple of these walruses right here, and I go, do you think it would spread quickly? And everybody's like, yes, because they're all like on top of each other. So diseases are an example of something that would be referred to as density dependent. They're going to spread faster in a dense population than they would if all these walruses were spread out, like far away from each other on the island. Then we have factors, I'm going to give you a couple examples here before we go on, that are called density independent, which it doesn't matter how packed together they are. These tend to be really large-scale disaster-type situations. So for instance, let's say this island isn't very big, and it's a volcano, and it just erupts into some giant eruption. It wouldn't matter if there was 10 walruses kind of randomly scattered around this island, or if they're all on top of each other like we see here. If this eruption is big and destructive and just blows up the whole island, they're all going to die regardless. Like, it won't matter how dense they are. So that's the two types of density which we're going to get into now. These are the two types